Welcome everyone to our Ag Forum. It's an annual event we have during Agriculture Awareness Week, which is an event sponsored by Alpha Zeta. We bring animals to the brickyard, and the whole purpose of this week is to increase agricultural literacy and ag awareness on campus. So today our forum will be about being in the know about GMOs. So our chair has found some esteemed panelists to come and have, a very thorough discussion with everyone about what genetic modification is, some of the questions we got from the brothers, and any kind of insights they can give us from the industries they are working in. So first on our panel, we have Dr. Jacob Dums. He is a biotechnology teaching postdoctoral scholar here at NC State University. He began his career studying biotechnology and plant pathology at the University of Wisconsin before pursuing a PhD here at NC State University. During this time, he studied the use of algae as a source of biofuels under Hype Cetera. After obtaining his PhD in plant molecular biology, Dr. Dums worked in viral and microbial ecology for 2 years at the University of Delaware before coming back to work at NC State. He is now a well-loved instructor and mentor in the biotechnology program here at NC State, where he is currently researching algae virus biology and biotechnology. And we are all very excited to hear about your unique perspective. Next, we have Dr. Allie Scott. She started her path with a bachelor's in agricultural economics before pursuing her master's in agronomy and agricultural economics, and then attaining her PhD in genetics and plant breeding here at NC State. Dr. Scott's background includes experience in both academia and industry, where she began in the quality control department before moving on to regulatory science. She has worked for Agreva, Aventis, Bayer, and is now working at BASF as the global head of regulatory affairs seeds. We are very fortunate to have Dr. Scott with us today, because she will be sharing her expertise in the regulation of genetically engineered crops. Dr. He is a senior scientist at R.J. Reynolds Tobacco Company. He is serving as the plant molecular biologist for the plant science group. His role is focused on plant molecular biology, plant breeding, and biotechnology. Prior to his current job, he worked as a postdoctoral student for the Department of Plant and Microbial Biology at NC State University. We're also very lucky to have him with us today as representative from R.J. Reynolds. Last, we have Dr. Dan Jenkins, and he is currently the head of regulatory and quality for Pairwise, a Durham-based biotech startup. His more than 20 years of experience in the food and agriculture industry has included being the managing director and chief of staff of the agricultural section of the Biotechnology Innovation Organization Trade Association in Washington, D.C., as well as leading Monsanto's regulatory team in Washington, D.C., where he oversaw all domestic chemistry and biotech crop approvals across the FDA, EPA, and USDA. Dr. Jenkins is also currently on the advisory board for NC State's Plant Sciences Initiative Center of Excellence for Regulatory Science in Agriculture. And like all the rest of our friends, we are all very lucky to have you today. So all of you were sent the questions that we as a brotherhood kind of compiled to kind of, get your brains flowing on what we're going to talk about today. So I'm actually going to move. So let's get started with, the reason why we're all here. So what is a GMO and how does it differ from genetically engineered products? Anyone?
Because I close you, so I can start. So, when I read this list of questions, I feel, back campus to do quiz. I hope, because the knowledge of life science changed quickly. I hope what I learned from textbook is still correct. So my understanding is GMO is the genetically modified organism. And just the scientist specifically modified genetic material of one organism. For example, just transfer some genetic material, DNA, from one organism to another. This is genetic modification. And this process is called genetic engineering. So in my opinion, they're saying, actually, I think it's since this year, January this year, USDA actually released a new maybe rule how to label the GMO product. They actually label the GMO product as bioengineered product. So kind of like that means bioengineered is same with the GMO. Yeah, that's my understanding.
Anyone want to add?
Sure, I'll go ahead and add a little more. Genetically modify is a very wide term, and if we are truly honest, we are all genetically modified because nobody is the same as another person. So genetic modification happens normally. What we call genetically modified, and when we talk about GMO crops, we're really referring to a type of genetic modification that is artificially done and that has the caveat that you put genes from one organism into another organism that of a different species. So basically that this combination would never happen in nature. And this is what the majority of the countries regulate and see as genetic modification as GMO. Of course, there's a caveat, and if you ask me what is GM, I would say it depends. And I'm not trying to get out of this, but what I'm saying is that different governments regulate different things, and some governments regulate the process of changing the DNA. Other governments regulate the end product. So does the end product have a gene or genes or any component that could not have gotten into that product by nature?
So I'm gonna add a little bit too.
No problem.
So we've already run into the issue of depends on who's defining it and under what regulation. And I think most people, when they think about it, they're really thinking about something that comes from another organism and could occur naturally. And if you look at some of the history here in the regulations, the term GMO isn't even used. It's LMO. It's living modified organism. And that's under something that you could look up if you want, but it's something called the Cartagena Protocol, which then laid out what do we call these things, how do we define them, and then lots of countries around the world use that as the basis for the regulations. So I took the time to look at this, but possesses a novel combination of genetic material obtained through the use of modern biotechnology. If you look at what the EU says, well, they said in one instance that it's genetic material has been altered in a way that does not occur naturally. If you look at what the European Court of Justice said recently, it would say that anything using chemicals to make
A technique.
a mutation, which is how we made ruby red grapefruit, those are all GMOs. So I think commonly how it's understood is foreign DNA and couldn't occur naturally. But the regulations may say different things, it depends, right?
Don't know if I can really add a whole lot. Very, very thorough. But yeah, I think it comes down to, like it said, semantics and how you're defining things. Because you can have cisgenetic things that are not from a different organism, but are still modified. Likewise, you can cut out a single SNP, and that's modified, but is it detectable? Does it fall into something new? You know, it's very fluid. I'm still working out the terms, I think, for a lot of things.
Well,
No, yeah.
well, under the labeling, the National Bioengineering Food Disclosure Standard, which is the GMO labeling law in the US, it came into full effect on January 1st. What that says is that you're a GMO if you've used these modern techniques, unless you're something that could have been found in nature or achieved through conventional breeding, then you don't get labeled as a GMO. So if you're using a technique like gene editing, say, well, we've made a mutation, a change that we could have achieved through conventional breeding, or it's already out there, that wouldn't be a GMO under that, right? So, depends.
So, by the way, how many people have noticed the new labels from FDA?
USDA.
Yeah.
You notice it? I barely notice it. It's a good question.
We touched a little bit on like the individual products. So could you, for those who may not be aware, could you touch on what are some of the genetically modified products that are commercially available that are like the certified GMO?
You start.
For starters, there is no type of certification, okay? So a product is, you modify it to have a trait, an added trait, something that the plant couldn't do before. The majority of the products that are in the market today, or that have been retired, contain the ability to survive the application of a herbicide that otherwise would kill the plant. And this is done for obvious reasons. One of them is because you want the farmer to go into the field as few times as possible, or you have the farmer having so many different types of weeds that the number of times he has to go with different herbicides is not convenient, or is really depleting his resources. At the end of the day, several companies came up with very broad spectrum herbicides that will basically kill about every single weed and would allow the crop to survive. It was so successful, and it really truly enabled no-till and a lot of modern practices, that it was adopted very rapidly. The second trait or characteristic that has been widely used is the resistance to insects. And this is done through using a toxin that is normally produced by a bacillus. It's the BT toxin, Bacillus thuringiensis. And what happens, and this bacillus, it comes in pellets and you just throw it in the field during organic farming. But what we have done is we have taken the actual crystal proteins from inside the bacillus and taught or made the plant synthesize them. So it's almost, the difference is when you have a herbicide, you are making the plant either detoxify or tolerate the herbicide. When you have an insect resistant protein, you are producing the pesticide inside the plant. And whenever it touches the insect, basically it has its effect. And I would say that those two have been the products that brought GMO to the attention of everybody since 1987. And at that point, when we started introducing things into the market till today, where 98% of the soybean planted in the US is GMO, a similar percentage in corn. It's really amazing how much it has been adopted in Brazil and Argentina and Canada, and basically in the Americas, with 25 years of history of having zero adverse effects and hundreds of millions of dollars in studies to prove the safety of the product. So there's a lot of more niche characteristics like oil quality. We have everybody. Do you know what hybrid vigor is when you make a cross? Well, you can cross corn by making one line male sterile. In canola, you can't. In canola, both the anthers and the pistils are all in the same flower. So we devised a way of making, through genetic engineering, a way to make the canola flour sterile. So we were able to produce hybrid canola, which yields about significantly more. We're talking almost 3/4 to double. And that has been really one of our biggest success in addition to the herbicide tolerant. We have nail sterility, there's drought tolerance, there's a number of insects, not only lepidopteran pests, but also coleopteran pests. Now we have Bayer came up with the thrips, dry bone cotton, tolerant to sucking pests. What else?
Virus resistance.
Virus. Oh, this story. This is the poster child.
Yeah, absolutely.
The papaya would be wiped out of our country if it wasn't for genetic engineering. Devastating virus that was conquered through this.
Yeah, for example, I think when people talk about GMO, they talk a lot about like soybean, corn, but actually the organism, including the plant, animal, and also micro organism. So actually the insulin people use, the pharmaceutical industry, they use a lot of GM bacteria to produce insulin. Yeah. So that's also a product that actually a lot of people use.
In cheese.
Yeah. Good. For the bake, that's up for cheese. Beer. Yeah.
Yep.
So when you look in a lot of the countries in Europe, for example, who are anti-GMO and row crops, they have little regulatory carve-outs that allow for their use for making food ingredients and for making medicine.
Yeah.
So they don't care quite as much. But just to round things out, so you have GMOs in about 10 crops, right? So it's apple, potato, you have a non-browning apple, you have non-browning potatoes, corn, cotton, alfalfa, right? Soybean, canola, mentioned sugar beet, yeah, and papaya, and squash. So squash, about 30% of the, I think it might be off now. Oh, brinjal, eggplant, thank you. Yeah, and then squash is about 30% of the squash. Summer squash that's sold is yeah, and rice, right?
Rice,
of course.
Is viral resistant, yeah. So, and then there's quality traits. The pink pineapple is a new one. So add that to the list. Anybody had the pink pineapple? It is.
I want to.
Yeah, it's
I've wanted to.
Yeah.
Really?
Have you guys seen the pink pineapple?
Oh, yeah, I've seen it.
Okay, it's ridiculously expensive. It's awesome. I got one, and I let my daughter taste it. It's almost a watermelon flavor, but it's a lot like sweeter, and it's a stronger, fuller flavor. And I let my daughter taste it. Who's 13, and she goes, "Where is more of this? My kitchen." So we crushed it in 5 minutes, and that thing. But they go for like $50 a pineapple. And somebody had one and gave it to me because I didn't pay $50 for a pineapple. But that is the latest GMO, and it's grown in Costa Rica, which is interesting too. So that's the latest one. But there's things like that that are just what we call quality traits. You might have modified fatty acid profiles to make a better oil for frying, or something like that. Yeah.
Also, cotton may be a good example. It's not food, GMO product, but it's really important. Yeah, GM technology actually saved the cotton industry. Use the BT protein.
Yep.
And although it's not a food crop, but you really eat the cotton oil, Pringles.
Yeah.
Yep.
Yeah. Cottonseed oil is used a lot.
So you touched a little bit on like the international impacts and how they react to it. Could you maybe expand on that some more?
That's a long sentence. Yes.
Take a continent. Pick one.
I think where I would probably go with this is it's interesting to see where things went with GMO, and maybe pivot towards where things are headed with more modern technologies like gene editing. So my company is involved in gene editing. We're based here, and we're working on using gene editing to improve fruits and vegetables. And so GMO, which we've lived through, wow, quite a lot of backlash there, right? Particularly and very restrictive. And so what you saw all over the world was in places like the US and some others, South America notably, that had regulatory systems that allowed you to get through and then cultivate and sell your product. And a lot of the rest of the world started off by signing on to the Cartagena Protocol, which I mentioned.
Yeah.
And then when countries adopted that in some form or fashion to make their own regulations, things got really restrictive. And so around the world, from our standpoint, trying to get stuff to market, it got really hard and really lengthy and really expensive. And so as a result of the impacts of that, you saw market concentration. So you see that in several variables, right? You see that in what kind of crops you work in, ones on tens and tens of millions of acres only to make it worth it. Traits like herbicide tolerance and insect resistance, which you can put on those tens and tens of millions of acres, and only in certain crops, right? Then only certain companies could afford to go through, to run that gauntlet globally, to get through all the approvals in Korea and Taiwan and Singapore and Brazil and Argentina and Europe and Australia. It's a lot. So that's what happened. Now, with new technologies like gene editing, and I'll try to be concise here so others can weigh in, we see kind of the opposite. That where Europe, again, has gone kind of restrictive out of the gate, the rest of the world is going in the other direction, not following their suit. So, and Latin America is leading the way, I would say.
Yeah.
Yeah, and so, and when we see data on people that are younger like yourselves, we see more acceptance of technology in food. We recently saw the European Commission come out and say we have to have new technologies like gene editing to hit our sustainability goals. Wow, that's different. Didn't expect that. The UK, that has broken away from the EU because of Brexit, has come out and said we're making regulations here that allow us to use things like gene editing. So you see a shift, and I would argue that that really difficult and narrowing impact has actually led to, oh my gosh, we can't repeat that mistake. And you're starting to see a democratization of the use of the technology. So final thing I'll say is Argentina, which has good regulations with respect to new technologies like gene editing, has learned some lessons from the past. They published an article that said, when we look at who's applying and the different things they're applying for to get through classic GMO stuff versus what we see in gene editing. In GMO, it's the big companies, it's the big crops, it's the same traits. When they look at gene editing, they see we've got academic institutions, we've got smaller companies across all kinds of a variety of crops and animals, and a variety of different traits they're trying to create. So I'd see that big negative thing that I know I lived through with people protesting with guns outside of our office, to now where people are going, we need to change our ways a little bit. So I'm optimistic. I think that's the impact of the negative stuff. Yeah.
I think I'm hurting still from the negative
I have
side.
stories.
I don't know. Just to give you a little bit of background, I have teams in 29 countries just to get approvals. And those are not even all. I would categorize them from like the Americas being the exporting countries and the rest of the world being the importing countries. As long as the trade works that way, I think it's what has been defined. Now, what's going to happen when China, Russia, they start exporting their stuff? I think that the overall thought process is going to change because they have always been very restrictive in terms of what can get in here. And now they're going to be the ones getting the other way. I do want to make a comment in terms of genome editing. By the way, I call it genome editing. You call it gene editing. Which one is right?
They're both are.
Depends.
Does. Well, I mean, like you look in the literature, people use both.
Okay. Anyway, when we look at that, the majority of the countries regulate genome editing. They just have ways of exempting certain products, but it's not that it's a free, that anybody can do whatever they want with this. It's still to take a look at it. It's just a regulatory burden. The studies, sometimes that you can submit a paper argument on why this should not be regulated, but you have to ask permission. And the scientists in the different governments take a look at it and make an educated decision. I fully agree that it's going to be much easier to bring to market. However, all it takes is one country to ask you for the information, and there goes $135 million just to support the safety data of one product. So yes, you may save some time to the market, but as long as Europe regulates this, as long as China regulates this, it's still going to be
For commodity grain.
expensive.
For commodity grains. So for us, we're focused on like a fresh market and domestic. We don't need those approvals.
Okay, because you wouldn't be exporting. Okay, I work only on commodities.
Yeah.
All right.
And
we
the
can be
commodity
friends
things are,
again.
yeah, we can be friends, Ally. And the commodity thing is really important, so all of you understand where we were going there.
Got it.
Fungible is the name of the game and grain. And if you don't, you can get all the approvals you want, but you have to deal with every
The one.
government. And so the tail wags the dog there. If there's one out of 30 or 40 countries that says, sorry, you got to do all this stuff, then you got to do it all. And because it can go be traded anywhere in the world. So it's not an issue for us if we're selling seedless blackberries in the United States all day. We're not worried about it being held up at a port in China. Okay. Yeah. Still fun.
One of the things that we were discussing, because as you guys have seen, most of what we have to debunk is how the genetic modification will affect like human health. Can you give any background on that?
Give lots of
Yeah,
background,
same.
but I want
Yeah.
to make sure that I don't want to be taking over this. So
It's kind of like you said, years and years and years of this happening and nothing being shown, also nothing being shown in the animals that are consuming this, it doesn't hold up over time. Granted, you can create something that could be a problem. That's part of why there's the regulation, the testing, is to know that.
as a professor, do you feel that there's that defiance on the science? Is there a concern from the new generation?
So since I'm teaching primarily science-focused students, I often don't get a lot of pushback on things because that is, what they're dedicating themselves to, and they're taking the time to like study and understand and know like the consequences of what's happening. Problem is misinformation. All you have to do is like tweak the story a little bit, and then it turns into like a horror story or something post-apocalyptic, and it's very easy to do that. We have a lot of media, we have a lot of way to say things these days, and so that's part of where a lot of that comes from. Is part of what you've lived through a lot more. I'm fortunate in the fact that I've been at a place where I've had to encounter that. But yeah, within my classes, there's little to no pushback. And in fact, I have to do the opposite. I usually have to play devil's advocate on the other side, because sometimes when you defend something too aggressively, you're just turning off the other side anyway, and you're shutting down any type of conversation. And part of that dialogue needs to be like open conversation with people that are willing to shift on both sides if given like the correct information. And so that's it's part of what I try to get across to students is emotion is still part of what you're talking about, even though we're talking about science. Humans don't run like computers. Like we still have emotions, we still need to talk to each other, we still need to connect. And so making those connections, doing that communication like that is very important, especially when you're talking to those who might not agree with your standpoint, because sometimes that's ignorance, sometimes they have very legitimate concerns and those need to be heard and addressed. Just shutting it off without any conversation usually gets, nowhere.
I think that that's the biggest issue. The issue that the people that understand the science are not vocal. They're happy, they understand it, so they don't have a problem. It's the people that don't understand it, the ones that have a very, very loud voice, and a voice that will not respond to science. In terms of safety, to me, it's almost like a non-conversation because it's right there. You can see it, every reputable journal, every reputable company, every reputable Professor Nobel Prize, whatever you want, the data is there. There's nothing that points out that anything, and I'm going to say this very carefully, that the product is not any more dangerous than the same product before it was transformed. And I say that because soybean, there are people that are allergic to soybean, okay? And by making them GMO, it's not that nobody's ever gonna get sick of touching soybean, but it's just not gonna be any different from the plant before you alter it. So.
Yeah, I wrestle with this question for all the reasons we already said. You can point to National Academy of Sciences published, basically nothing to see here. European Food Safety Authority, 10-year retrospective, nothing to see here. And when you think, if you understand just a little bit about the process of making it, then it's all transparent. All the studies are out there. You can read the documents that companies have submitted.
Everything is public.
It's all out there. But it takes a lot of effort to read it and understand it. So charity for that. So, and so ultimately, if somebody just is coming at it from an emotional standpoint, you've got to have a little sort of, again, charity for that. But in the end, there are objective facts here, and that's what science is about. And you can present that to them and try to relate to them so that it has a higher probability of sinking in or getting over the line. But there's no question about the safety of these products ecologically, from a toxicological standpoint, allergenic standpoint.
I think that the grudge is not with the products, it's with the institutions that create them. And unfortunately, there's a lack of trust on big corporations and the big corporate farms that can, and there's always something romanticized about the small farmer and the one that can't afford. There's a couple of stories that make it to the media. When you look objectively to what has been done, again, there is no risk, there is no hazard, there is no damage, and the science is there. So then why don't people consume it? And I'll tell you a story about labeling in Brazil. What was it? Over 10 years ago, the Brazilians decided that, transgenic need to be labeled. And they made a pretty cool label, I thought. It's a triangle, like the real triangle, but upside down. It's a triangle with a yellow, with the borders black, and a big black T in the middle. That's transgenic. The government said, yep, everything that contains transgenic has to be labeled. Well, guess what? Everything has the label. Doesn't mean anything. Nobody stops buying anything. But it's about trust.
Just, for me, yeah, tons of science data already confirmed that there is no difference between the GMO product and the other product on the human health. Very basic factor is we intake a lot of genetic material from other species organisms. You worry after you eat a salad. You worry you eat a fish. No one worry, right? Eating fish will not improve your swimming skill. So
I like that.
yeah, I hope I can improve my swimming skill. You just eating fish, but unfortunately, it will not change you. So yeah.
But there's a lot of things that we check, and I want to assure you, it's not that take my word by all this tests we have done. We really evaluate every single aspect. So we check that whatever we put in the plant is exactly what we intended to put. We do genetic sequencing of every single chromosome of the plant until we find the part that we put in, and we make sure that nothing else was put in. So we do extensive DNA analysis. Then we check that the gene that we put in works, and we check how does it work? What amount of protein in the leaves, in the stems, in the roots? At what time of the year, or what age of the plant? We analyze all that. Then what happened to the other stuff in the plant? What happened to the micronutrients, the macronutrients, the amount of protein, the amount of crude oil, the fiber, every single, is it the same as it used to be before you change it or not? And then we go into, does the insert stay there? We cross it with everything that you can imagine. We test it for generations. We test the toxicology. When the gene got into the plant, into the genetic, into the DNA of the plant, did it disrupt anything? Does the plant look still like a plant? Does it look like a soybean? Does it yield like a soybean? Does it flower at the same time as the other one? Everything. So it's, from a scientific basis, it's a very robust background. We do, we test that the new product is not only safe, but it's as identical as possible to the original. And so is the new one, with the exception of the new gene we put in. And for that new gene, we do all the toxicology studies, we do digestive studies, we do everything we can think. So there is not only the weight of evidence of history and us consuming this forever, but it's also a robust safety package that is presented to every single government and that is fully available for the public to understand. So I just didn't want to leave you like, hey, trust me, it's safe. This is a very brief synopsis of all the things that we test. And if you're interested, there's a class in the university, CS 520, that you can take to learn more.
That last point you made though is really important.
The
So
class?
no, not the class. Not important, but it's hard to get people to understand like. So you do all the things that Ali described in showing the plant is still equivalent to an untransformed plant, and then for the thing that you know is different, you do all kinds of safety studies on that. But then you've got to go through how many countries and all of them.
29
right
now.
Yeah, I had 27 in my head. Maybe it's changed. So, and each one of those countries has typically like an FDA and an EPA and an USDA. So you have to get through all of those agencies and all of those 29 countries and all of their data, questions, and reviews through all of them before you launch a product. It's enormous. So it's well tested. It's
14 years. I'm 35 now.
yeah, it takes a long time. So anyway.
In average.
Now that we've kind of expanded, obviously, on human health effects, when you take a look at environmental effects, when you plant like a transgenic crop in a rain field in southeastern North Carolina, like what some of the misconceptions that we've encountered is, what if the pollen goes to the field? How is that going to affect it? Like that kind of thing. So can you want to expand on that?
It goes back to what Ali was describing. So you have to you end up doing all kinds of studies. You do insect collections,
Pollen flow studies.
pollen flow studies.
Pollen morphology studies.
Yes, pollen morphology.
Don't ask me why, but the Japanese want it.
Yeah, that's right. Yeah, protein expression and all of it. And you do all those studies, and a lot of it's dictated by the regulations themselves. Sometimes you'll come in with something and they do what's called problem formulation. So you think about the product and the environment you're introducing it into, and out of that analysis, you'll go, well, there's some potential hazards and exposures. So why don't you guys go and do these studies and measure insect larval head capsules and see if they're affected if they eat pollen all day long. And you do all these studies and you look at degradation of it in the environment, and you do all those
Do
studies.
environmental fate.
Right, environmental fate, yep.
You do studies on the metabolism of the herbicide that you're applying, because you obviously are applying more of that particular herbicide.
Filter feeding insects in the streams, you do all that work, right? Whether it affects butterflies. And so you do, and that can depend, what you have to do can depend on the nature of the trait, as it should. So if you don't have an insecticidal trait, you probably won't be having to do a lot of that stuff, right? But if you do,
Whales.
then the problem formulation would say you need to.
And I would say the effect on the environment, that very transparent here. The effect on the environment is agriculture. Has nothing to do with the GMO or the non-GMO. Okay. The herbicide tolerance. Yeah, there is a possibility, and we have all seen it, that when you apply a selection pressure of just using one herbicide over and over and over again, year after year, crop after crop, weed tolerance will develop. It's not a matter of will it, it's when. And all you do by exerting pressure, a selection pressure like that, is that you just make it happen sooner. I want to think that farmers are much smarter than me, and that they figure it out that they should not do it again, and therefore they should rotate herbicides. Now they have the luxury that there should be 4 or 5 herbicides that they can spray over their plants and they won't die. So rotation, integrated management of the farm is key to maintaining. About pollen flow, will it happen? Yeah, it's biology. Does that matter? If you have taken population genetics or something like that, you will realize that unless there is an effective selection pressure, we already proved to you that there's nothing different between a GM plant and a non-GM. So they shouldn't take over the world, because you're not selecting them with an increased pressure. So yes, I'm not going to say that, the pollen will not leave your field. After, it will not leave your field while we're testing it, but after it's approved, yes, it will, and there's going to be mixes, but there are mixes already. And there is no evidence that that is dangerous in any manner, other than, it's very hard to have pure anything nowadays. So if you want pure non-GM, you're going to have to pay for it, because it's harder. The air is full of viruses and of pollen of different crops.
So since we're kind of nearing the end of our time together, and I want to make sure we get to some of the audience's questions, the last thing we're really curious about is, what do you see on the horizon and as far as marketing policy, what you're doing in your individual like perspectives of the industry, just to kind of run this out there.
My dream or the reality?
Both, if you really want it, if you feel like sharing.
Yeah, in the future, like now now we have, yeah, in my opinion, just there has been a controversy of the GM or gene engineering technology, since these technologies were developed in like 1970s, I think 1970s or 1980s, like that. So I remember one very famous picture is the cover of a Time magazine. So the scientists built a giant snake, and the body of that snake is a double helix, showing us like how much people worry about like this technology at that time. So this kind of a motivation for scientists to do more research and keep improving this technology. And, I think in the future, yeah, scientists will keep doing that. Now we have the new next generation gene editing technology. I use gene editing. So gene editing technology, it can accurately change the genome. Same with the traditional breeding variety. And yeah, I think in the future, yeah, the GM or GE technology will help us a lot. And now, we have a lot of issues. We have climate changing. Maybe in 10 years, North Carolina will be warmer or colder. You cannot use the same variety to grow the same thing. That time you have to change it. The gene editing technology give you a lot of flexibility. You don't need to change other traits. You just accurately change one trait. Let them get used to the new condition. And yeah, so yeah, there will be a really good future for the GM technology.
Right. And my dream is that, the governments and the people would accept that, it really doesn't make any more sense to waste taxpayer dollars revising another Liberty Link or another Roundup Ready crop, but they just let it be. Realistically, regulations are not going to go away, and regulations not only is a matter of sovereignty, but it's a matter of demonstrating to the public that they're in charge. And I can see them continue to escalate the burden to develop things. But I don't believe that we're going to go back. I think that we're not going to drop GMOs ever. They will just become more select, and there were going to be more crises like papaya crisis or like herbicide resistance. I need to come up with something new. And there's not a whole lot of things. I truly believe that genome editing is the future. As a technique, the trick is going to be, the technique is there to change whatever you want. But finding what to change to make a significant impact, that's the trick. And that's what can probably cost you another $100 million. So I think that these technologies, it's going to be a washout. And why not a combination of both? I think that in order to survive the amount of people that we have on this planet, the crisis on climate, the irregularities of commerce, we're all trying to figure out where Amazon is today and where FedEx left my package. If you think there's a big scale, the challenges that we have in the future, we're going to need every single technology and every single garden pot that you have to grow our food or to grow food, like in the commodity food for cattle and for animals so we can eat cats. So
So I'm very optimistic and excited. And what I'm hopeful for is that we can start to deliver things that directly impact consumers, that they get excited about, that you get excited about, right? That connect with what you want and hopefully your values too, that we can deliver on things like sustainability. So I can tell you, but I can't tell you all of it. I mean, I've gotten determinations now from governments in 2 weeks that you're not a GMO. We'd love to have you here. And this is for us in my company, we want to improve people's diets and their health. And so I'm excited to do that without having to wag my finger at them or anybody wag their finger at me to eat more fruits and vegetables because I'm terrible at it too. So I'm excited about that possibility, and we see reasons for hope from the European Union, who's now trying to create legislation to, oh my God, change this decision that they had on things like gene editing. When we look at the data, I've had to learn that marketing is a science, and it is. It is a study of populations and use statistics, and that most people don't know anything about any of this stuff. It's a typical curve, right? Bell curve. 20% don't want anything to do with it. 20% are fine with it. Everybody in the middle is like, I don't know, show me something. So I'm hopeful that we can, and I think that the regulations are going in the right direction. And as we continue to do our part to deliver on bringing those things to market, I think the regulations and the policy and the acceptance will go up. And that, I hope, benefits society overall. So I'm excited about that possibility, and things seem to be going in the right direction right now for these newer technologies.
I gotta say that they're not just going. There's a lot of work from a lot of people, a lot of associations to try to make the government see the light, make the benefits.
Mhm.
So it's not just out of luck.
Yeah, that's true.
Yeah, I guess from the education side of things, I would say, at least on our goal, is teaching more people about the science and the support behind it. People are afraid of what they don't know, what they don't understand. So if you can give that to them, that's very important. Linked with that is how to actually communicate with people. Scientists do a lot of talking with each other on a level that the layperson does not relate to in any way, shape, or form. We also have a whole set of rules in our communication that lay people also do not have. And so part of what we need to do is to, at least in education, it's yes, you know what is happening, you know how this is working, but also you can relate this to other people. This is not a conversation that you only have to have with other people that are in the know. You can talk about this with family members, people in the streets, I guess, if you want to go advertise, go to your churches, you name it. And I think it's really important, at least, to give the communication skills out. Scientists, as we know, are awful communicators in general. I think that is part of our training. We're taught as scientists to remove a lot of emotion from what we're doing because it's a variable. Problem is, we're humans. We can't get rid of variables that are us at the same time. And so it's more in controlling and embracing those and also using them. Emotions are a large part of communication, and we shouldn't shy away from that. It's part of why some of those trust issues come up. Is it's you're talking to a robot that will only spit out facts, but actually won't talk to you about I'm worried about my daughter eating this and affecting her DNA. And it's not no, that's just not going to happen. It's this is why it's not going to happen, because this is the reality that you have to be able to be empathetic enough to actually sit down, have that conversation, and speak on a level that works for them. And so at least my hope is that for education, we continue to give these skills out. That and just the generalized knowledge, because I also think gene editing is awesome and like on the cutting edge.
Yeah.
We're doing it in, I teach a plant genetic engineering course, obviously like this.
Yeah.
And so like CRISPR-Cas in class because
Yeah.
I can. And it's cool and it's simple in a way. And sure, there are ways that it can be weird and you can manipulate it, but a lot of it is just intention of what you want to do. And in general, we're not evil people. Like I don't have actual evil intentions when I'm doing this. And so, and that's all part of the regulation and the testing and those comparisons. Like, yes, no, this works. And so kind of like, at least for, education, it's just like getting that across and also like inviting other people to spread the word in a way, because we should just be sharing knowledge, period. Like,
Can I ask him a question?
Yeah, of course.
Do you find it useful at all in some of the gene editing discussions that you can bring in human therapeutics into the discussion? So for example, I'll start off a conversation talking about cures for sickle cell anemia.
Mm-hmm. Yeah. In general, people relate to the
That's different than GMO. You couldn't do that, right? So
yes. But yeah, if you can relate it to that person as directly as possible and then extend towards what you want to talk about, always helpful. As plant people, we know that we get less funding because people don't care because it's not a disease that affects me. And so like, yes, if
And,
you start with
and you
sickle
have
cell-
other options.
yes.
But again, we thought about that by doing plant-made pharmaceuticals
yeah.
because we thought that that would be more accepted.
But yeah, starting those conversations by getting down to those person's values, because you mentioned it's part of your company structure and mission. It's like, connect with a person on their values, see how that connects with what you're talking about.
What you say is so true. I have such a hard time finding good scientists that can talk. And I don't know if they're mutually exclusive. I mean, do they share the same loci? I mean, what's the problem here?
I think it's years of training. It's
But
literally
I can
years of
tell
training.
you, and I get a lot of candidates to my teams from research. They always want to end up in regulatory, which by the way is just a fantastic area to be in. You get to play scientist and to play politician and then to go to the field and mess around in the tractor. I love it. But I always tell a good scientist ends up the research with more questions. A good regulator, at the end of your dossier, there is no question. You have explained everything that you could possibly imagine and the additional questions that they were thinking about asking. Being able to not rebuke, because I think that there's this terrible desire not only to share what I have, but to change the other person's mind. And I think that what we need to do is aim for respect of the differences of opinions. And I think that if we could only achieve that, it wouldn't be so harsh. When I am in a panel like this with NGOs, with people that truly and firmly believe things are very different to my beliefs, the attack is never to the plant. They may be at the beginning is to the plant, at the second time that they open their mouth is to the company, is to you as a person, is to the greed, to the money. It's always about something else. So again, just step back, acknowledge where their anger comes from, acknowledge that you don't have the same knowledge that I do. That's why I'm old. But I think that by starting that, not getting defensive, that was the hardest part of my transformation from a scientist to, I would say, more of a policy person, a regulatory person, was to bite my tongue, listen, and acknowledge that they felt that way.
Now, for audience questions.
So I guess I know a lot of us here are very interested about the impact on a grower or farmer, especially both in the United States and worldwide. How is the effect of something like, I don't know, large corporate patent laws on the use of these GM products kind of affecting the socioeconomic status of those farmers, or how would it affect them in a legal battle if something were to happen?
So for the same reasons, our technology is available to everybody. Okay. So the idea of making the technology available is that you are not paying just to be part of the club. You are paying because your return on the investment is going to be there. You're going to make the money that you put in when you harvest. And that is why it's expensive. I told you how many years it takes. You know how many years a variety lasts, between 3 and 5. So somebody's got to pay for all this research and all these studies. And that's why we put fees on these particular products. Now, I think that the biggest, I would say, handicap of certain farmers, and I have not seen this in the United States, but in other countries, is the ability. You wouldn't use highly technological products if you don't have the equipment to go with it. I mean, there is no point of going with a hand sprayer through an acre and having GMO just to survive the hand sprayer. I mean, if you're going to be walking the field, might as well pull the weeds and don't spend the money on this. And getting access to the big harvester, the big tractor, it's complicated. Okay, in smaller countries. There are ways that I've seen it accomplished. They have these cooperatives where they all get together, they buy one tractor, they share it among themselves. I think that overall, I think that just managing the land the way that has been managed for centuries is no longer an option if you want to survive. Might as well sell your land for a neighborhood, make a lot of more money. But every time that decision is on the mind of the farmer, I think that they have to advance and they have to invest, and the majority survive. But the other thing that is kind of playing a big role in this is how many more young folks want to stay in the farm. And I think that's a struggle that we all have. And I mean, I'm coming from a South American country where, you know, the land is everything. And we see the struggle to get people interested. I mean, you obviously are here and you love agriculture just the same as we do, but I try to convince all 3 of my kids to go into ag. I don't know if it was because coming from me, but it's just not interesting. You want to be in Wall Street or doing brain surgery on somebody. But
Can I add to this on the question of the patents? So what Ali was saying about up front, that you make this arrangement with the customer and say, look, we put a lot of money into this and it's patented, and you explain that all, and then you come to an agreement. But the agreement's based on it's a much better product, so you're gonna have to put less inputs into the system or whatever it may be, or higher yields you get out of it, so your margins will be better. We're going to share that. So the person working with you knows that. And then if it turns out that they're violating that agreement, what typically happens is it's because farmers around them have let the company know. That person is cheating and I'm not, and we're paying the same amount. And so then the company goes out and the company doesn't want to get in a bad spot with the customer, or maybe violating the patents, right? So you go out and you talk to them and you go, what are we doing here, right? Please stop, let's work something out. You do that a couple times. And then if they keep going, then the last thing, and it has taken a long time to get there, you get into legal issues, which is where your question ended. And so Nobody wants to be there. Patents are there for a reason. And you need that arrangement, and you need the patent because it has value. You need to get that value back as a company.
So
So
I
you
can
can
develop
reinvest.
them, exactly,
Yeah,
and
and
the
you can't do
money
it.
for the next one.
But if somebody's violating it, they're violating it. And so you need, you have to be upfront and honest with them and talk about all the ins and outs of it before you make an agreement. You have to do that, otherwise that's an issue. But you do that and you try to work with them, and that's what happens.
You
every time.
you
Yeah.
give them a lot of chances to make it right. So it's not like,
You know,
that they didn't realize. No, they have realized. We have talked to them a number of times. And to tell the truth, yes, those cases made the newspaper. But it's very rare.
but if you go and read the actual cases, all those people were found guilty, and it was no question.
Because
You-
they are real, so they can be
Yeah,
used.
you can go look up the court cases, but anyway, but has mistakes been
That's a
made,
different
have been mistakes made on the corporate side? Sure they have, but generally speaking, that's the way it goes.
Yes, Jen.
So what would you say to people that might not be against like GMO specifically, but might be against a company like monopolizing on the GMO seed?
That's a good point. Well, the first thing that I would say is I would try to understand what actually is that is bothering them. Many times when you make comments like a company that is monopolizing, it's a little bit of how do you say, when you a generalization. And when you look at it, it just looks like everything is Monsanto. It looks like everything is Bayer. But there's a lot of fighting going around. And there's a lot of little companies that are coming up. And a lot of our research comes from startups right here in your backyard that we buy their products from them. So this idea that we are like this big conglomerate that lives on the top of Mount Olympus and we don't come down and talk to, that is just not true. And yes, we work every single day to be the one and only, but we keep having these other three companies just beating us up every year. So there's a lot of competition.
That's what it comes down to. So when I was at Monsanto for a decade, and there was this perception that guys have a monopoly, right?
Yes.
And the truth. So the issue they're really concerned with is abuse of market power, and that's a tough thing. So a couple things there. One is that all the companies were definitely competing with each other. So I don't remember what Monsanto's share of like corn was, for example, but it was not 80-90%. It was probably,
And I can tell you
40.
today Corteva is
Yeah. So and then all the
messing with
companies,
all of us.
cross-license all these different traits to each other, and germplasms and all kinds of stuff happens.
That's a great
Yeah.
point. There's less and less of this is just mine.
It's not really there.
Everything is with everybody.
All those Monsanto kind of started a lot of this stuff, and what we did is we just licensed it out to all of our competitors too, so they could have it in their corn. And so the actual corn seed that Monsanto sold and owned was honestly, I don't remember what it was, but it was probably still a large part, maybe like 40% or something of the 90 million acres, or maybe less. I don't know, so you can check me on that. But that doesn't mean they don't have power. And so monopolies aren't illegal. The behavior that can go along with this, and so I don't know. Is Apple less of a power? I don't know. So they did have a lot of power. There was some bad stuff that happened. Not everybody's innocent, right? But I understand the problem with market concentration. But a lot of that market concentration came, I would argue, because of some of the regulatory had an impact on that, right? It was just again, big trades, big acres, and anybody who wanted to use GMO that could have been a competitor, that could have taken away that market, there's no way that they could figure out how to generate all the data, get through 29 countries times, let's just say times 2 to 3 agencies per country, and deal with all those questions, all that data and everything, and go through all that while your patent's running out, right? And sustain that 135, it's probably more now, millions of dollars. And then when you get into the market, and you've got how much time left in your patent, you're like, I need to charge you something.
3 years.
Your patents are abusive, you have too much power. Oh my God, how are we gonna get that money back? Like, so there was no competition, or not as much as maybe there could have been if policy that was really focused on meaningful sort of safety and things like that, it might have been better.
Selection pressure.
So, thank you.
Literally
Biology, thank you.
selection.
Yeah.
Yeah, I would also add like the argument there, kind of like has been reflected before, is almost never about the technology specifically. It's usually about like corporations or capitalism or human nature, if it comes down to that. Like that is usually what they're worried about, and they just see this as a tool. And it's kind of like you said, Apple, Amazon, we have a lot of different instances of this that could be portrayed like this. Why is this the one that you're fixated on? And usually it's something else at that point.
Yeah, I remember at Monsanto, we probably wouldn't believe this, but we wish there was more players in the market because we were such a lightning rod, but nobody else could get in. Anyway,
But just imagine if every professor that is working with GMO could take a product to market. Just imagine the variability that there would be. Just imagine the amount of products that you would have out there. And maybe the human trust, the societal trust would be better. But they can't afford it. And that is why they either license out or we purchase them, the products, and then we bring them to the market. But unless you have really, really deep pockets, it's impossible. I mean, the regulatory hurdle. I know that you tend to think of the regulator as the ones that are protecting me. And I'm not saying that they don't do that, okay? But to some degree, this becomes a little bit of greed also. You know, who can ask the biggest? And I have to tell you, I have a lot of respect for the American entities here, USDA, FDA, EPA. They really know what they're doing. They really have scientists. Try going in some other countries where the regulators are lawyers. We try to explain genetic engineering to them. They don't care. They want to know what kind of, did you use the paper that we're supposed to file? Did you have the 43 volumes? And then I don't know who they paid to read because the questions are completely not relevant from a scientific perspective. So you also got to think that this just increments the cost, if nothing else, of bringing a product to market. And it's just in case, you were saying how many countries, 27, 29? Well, we just got Indonesia in the middle, and that's the newbie. And Malaysia, and they have some really, and the amount that is shipped there is negligible. Nigeria, we just added them again. They came up with regulations. We have this practice that as soon as a new country comes up with regulations, we make a submission just in case, because we never know when the trade patterns are going to change. And the grain trade keeps telling us, oh, we want to start shipping soybeans to Nigeria. So there we go and make a submission to Nigeria. We thought we were done. And that it keeps growing and growing. And every year we have more countries coming on board. And every year the countries that we thought we already figured them out, like EU and China, come up with new regulations and new studies and new requirements. So it's not that once you get the approval, you're off the hook. Once you get the approval, you wait like 3 months and the approval expires, and then you need to get re-registration, renewals, and the cycle never ends. I have job for the rest of my life because this, I mean, just the amount of burden to justify certain things, completely agree. But agriculture, I mean, they could put the money in so many other places.
Well, the point is you take all those costs, you put it into the price of seed.
But where else am I put it? They would charge somehow.
Modern agricultural technology actually is expensive. Like a professor, they can develop something, they can test like a 5 acre, 10 acre, but it's not enough for you commercialize it. You need hundreds level at least. And also to make sure the product is safe, there is a very heavy regulation. So it's kind of like a cycle, right? Just you want to be safe, so regulation. And then only the giant company can afford this regulation and the field test and all these costs. So finally, you will find some company they hold
As you
everything.
know, a huge expense for us is breeding too. So don't
Yes.
go off that breeding is cheap. I mean, breeding is
Yeah.
expensive.
Traditional
I can
way
say 'cause
is
I'm a
not cheap
breeder,
way. Yeah.
It's a big, so it's the package, okay? I'm not gonna say that every study costs that much, but it's the package, because then you need to put in different germplasms for different things.
Did we answer your question?
Yeah, thank you.
You were yesterday in the classroom.
Are there any other questions? Thank you all for coming out, and I hope I learned a lot just by being up here. I hope everyone else did too. And yeah, that was awesome. Thank you. Thank you.
Thank you.
Of course. Shut this down, Raj.